What's going on, everybody? Welcome to the second video of machine learning with Python. In the previous video, we have learned about difference between artificial intelligence, machine learning and deep learning. But is it enough to understand this field well? I guess not. So here we are going to discuss of some other important terminologies which is often being used in field of machine learning and deep learning. So without wasting much time, let's dive right into it. Let's first see what is batch learning. In this type of learning, we train our model using all the available data. Then we evaluate the model whether it is accurate or not. If we are happy with the output, then we will launch into the production and run without learning anymore. So basically, in this type of learning, model is trained offline. That's why it is called as offline learning. But training using the full set of data can take many hours and lots of computing resources. So a better option in all these cases is to use algorithms that are capable of learning incrementally. Now, the online learning. In this type of learning, system is trained incrementally by feeding it data instances sequentially, either individually or by small group called mini batches. Each learning step is cheap and fast, so the system can learn as new data arrives. Online learning is great for systems that receive data in continuous flow and the system which is need to adapt rapidly. For instance, in stock market, we need to train model based on data arrives for better accuracy. Also, it's very good option if you have minimum computational resources. And how fast online learning system should adapt to changing data can be set by learning rate. There are different approaches to using the training data to develop a system that can be generalized to a new cases. Having a good performance by model in training data is always better, but it's insufficient. The true goal is to perform well in the new instances. There are two main approaches based on how ML system generalize. First is instance-based learning and the second is model-based learning. Let's start by taking an example. Suppose you want to make a system which can classify spam email. So instead of just flagging emails that are identical to known spam email, filter could be programmed to flag email that are very similar to known spam emails. For that, we need to measure similarity between them. We can classify spam email based on its heading or maybe based on specific words in it. We can generalize our model by comparing new instances with existing example by measuring similarity. So we can make our algorithm in such a way that it finds three most similar instances like itself, as you can see in figure. Then algorithm can classify whether the email is spam or not based on majority. In this figure, suppose square are spam emails and triangles are not. So according to it, new instance is classified as non-spam email. K nearest neighbor is best example of instance-based learning. I'll tell you how in the upcoming videos. The model-based learning. Here, we build model to make prediction. Instead finding similarity, we train the model from existing data. SVM, linear regression, decision trees, and neural networks are the best example of model-based learning. The fifth word in our list is overfitting, which is most often used word in this field. When the model performs well on the training data, but it does not generalize well, it is called as overfitting. In this image, these are the instances. Trained model should be like this, but it is instead like curved line due to overfitting. To solve this problem, we need to make model simpler. Instead polynomial, it should be linear. We have to remove unnecessary features. And also, more the training data, better it will be generalized. And of course, outliners. We need to take care of them. It deviates significantly from the rest of the objects, so it should be removed also. Now, making the model easy and reducing the risk of overfitting is called as regularization. Here, we have model which can predict college GPA based on SAT scores. It's a linear model, so the equation of line is y is equal to mx plus c, meaning it has two degrees of freedom. First, line can move in y direction and the second, its slope can change. In a machine learning model, there are two types of parameters. First is model parameters. These are the parameters in the model that must be determined using the training dataset. And the second is hyperparameter. These are adjustable parameters that must be tuned in order to obtain a model with optimal performance. For example, suppose you want to build a simple linear regression model using a training dataset. Then your model can be written as y is equal to mx plus c. Here m and c are the model parameters. With input data x and with label y, we can determine m and c. For that, we need to iterate our model in such a way that model become accurate enough. But we need to set number of iteration in starting which is called as hyperparameter. We can't change hyperparameter while training the model. Opposed to overfitting, here Model is too simple to learn the underlying structure of the data. To solve the underfitting problem, we need to select more powerful model with more parameters. We need to fit better features, and of course, we need to reduce constraint. Now, at last, feature selection and feature extraction. In feature selection, we select useful features from existing features. Dataset contains engine size, vehicle class, cylinders, fuel consumption, CO2 emission, and fuel type. So from that, we will select useful features. Here, vehicle class and fuel type are unnecessary data. So we will remove those columns and we'll select other columns as features. While in feature extraction, we make new feature from existing. For instance, if we have data of weight, height, age, and class, we can make new feature body mass index by dividing weight to the square of height. That is all for today. I know these technical terms are hard to digest. Please watch again if you find any difficulties for understanding. And if you still have doubts, feel free to ask in comment section. Thank you.